Hey everybody, this is Larry. This is March 13th, 2023. I'm doing an extra premium problem so that we can, yeah, we just could be medium for today, and one that I haven't done before. Yeah, doing a premium question, hopefully not a SQL one like that one. And let's try again. I need to just finish them so I don't have to run into the RNG again. Come on, friends. Come on, RNG. But yeah, basically I'm just, you know, paid for premium. Hopefully you want to do one problem with me. So okay. So this is a premium problem 484 find permutation. Permutation is, okay. So if S sub I is equal to greater than and then less than and then okay, let's see. So basically you have decreasing and then increasing. And you try to find one that's smallest. Okay. How do I do this? This is only a medium, right? Okay, let's say we have an I, right? Let's say we have all I's. And then let's say we have a D. And then an I. Does that matter? I'm about to do the lexicographically smallest one. So we can't just return any, we can just return any of them, right? So, okay. So, can I do it in a greedy way? That's the thing that I would probably try to guess. And some of this is a little bit of like just guessing and matter because n is 10 to the 5th. Maybe we can do n log n or something like this, right? And then the question is, well, where is the earliest one that we can place it? Like, given the number 1, where's the earliest we can place it? Well, if the earliest place that we can place a 1, it's going to be the first I, right? Maybe? Because if it's just like this, it doesn't really matter what it is, then you just put it in the beginning, right? And if you have like something like D in the beginning, well, then you know that the increasing, this is going to be a 1 there that goes to, say, maybe even right? And then the 2 will go to the left just because in theory that would be, that would kind of, right? So it'd be like 4, 3, 2, 1 or something like this. Maybe 5 because I kind of off by 1 or something, but okay. And then the increasing will be then now you have the next number. So is it just like ones of i's or something? Because then now you have di again. Now we can separate out to these two. I don't know if this is true. I'm just kind of playing around with it, right? So you have this idea. Then now in here you can have an individual 2, 1, 2, 1, 2, 1, 5, 4, 3, 2, 1 or something like this, right? And then now we have to combine them going from left to right. This is 5, so then this just means that we can do maybe something like 7, 6, right? Because we want to minimize this digit, and then now it's going to be 9, 8, well, 11, 10, and then what is this? Just going backwards, right? Is that? I think so, because at every point we're minimizing the first digit, so I think that should be good. Okay, maybe that's the way that I would think about it. Yeah. Okay. So basically, we do something like S split on I, right? What does that look like? So this gives. I don't know what the ideal thing is. Like, why is this emptiness? What does that mean? Maybe it's just always emptiness. I don't know. I don't know if split is what I want, but I'm just kind of taking a look at it. Right, so what would that look like? These. Okay, so this. Yeah, I mean, I think we have to handle the last number, but that's fine. Okay, let's just not do split of I. Maybe that's just making it even more confusing, right? So basically what we want is, okay, let's say we have an answer array. We have for C is an S if, so let's say we have a 1 0 0. This is one of D's. And then now if C is equal to D, then increment, continue, else, then now we have an I, right? What do we do with an I? Well, and maybe we put something like max or something. That's the number that we last insert, right? So then now we have a run of these things, right? So then let's say we have 4 D's, then that means that we want 1 plus 1, including for the I, right? Because if you have 4 D's and an I, no, that means that you have 6 numbers, right? So it's going to be 1 plus 2 numbers, and then yeah, so then I guess we just go backwards. Really, it's not different. It's not impossible. It's just weird. Let's actually set this to where n is equal to length of s plus 1. And then here maybe we just do an index, right? And we can even do something a little bit lazier, right? We don't even need, well, I guess we do. Maybe we don't need this. Let's just say we have I, right? So then now answer of index is equal to mx. We increment it by 1. Yeah. Right. And then now we do a loop for so let's say j is equal to index while j is greater than or equal to 0, and s of j is equal to d, or is it minus 1 maybe. Then answer of j is equal to mx, increment by 1, right? And that's pretty much it, maybe, except for at the very end. At the very end, we just set j is equal to index minus 1, so maybe this part. And index minus 1 should be n minus 2. Maybe something like that. Let's see. Maybe I'm off by 1. But oh, I also have to get rid of the infinite loops by actually decrementing. Okay, so we definitely. Oh, do I do this right? So if I okay, so maybe this does start. The 1. Yeah, because this is now. What the last characters an I? I guess last characters are fine. I is fine. Then now we want answer of n minus 1. Oh, yeah, n minus 1 is equal to also increment. I missed that pre-increment. variable. But yeah, should be okay. I mean, it looks good for these three. Looks good for me, unless I missed a zero case. So yeah, what's the complexity here? This is going to be linear time, linear space. You can't really do better than linear space because that's the size of the output. In terms of linear time is also the lower bound because you have to look at each character once. Even though there is a for loop and a while loop, this is only linear because the J will only look at each character once, right? Because this can only be true. So this loop only goes if you see a D and if you see an I afterwards or something like that, right? So for every D, it only gets executed once. So this is why this is linear time. Don't know if that makes sense, but basically you can think about it as there are 2 pointers, right? One that just goes forward, which is the index one, and then once you see an I, it just goes back to the last pointer, last I. So that means that you just kind of fill in the gaps every time as you go forward, which is why this is linear time. Even though it looks very interesting, so it's possible that it looks a little bit scary in that regard. But yeah, cool. That's all I have with this one. Let me know what you think. Yeah, daylight saving times is kind of screwing me up a little bit. So I don't know. I need to sleep a little bit earlier or something like that. Anyway, yeah. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.